One sunny afternoon, you are out by the sea. You step into a small boat, steady yourself, and prepare to dive into the water. As you leap forward into the sea, you notice something surprising. The boat moves backward. Why does this happen? What causes the boat to move in the opposite direction when you dive? To answer these questions, let's explore the law of interaction. The third law of motion, formulated by Sir Isaac Newton, describes the relationship between forces when two objects interact. It states that for every action, there is an equal and opposite reaction. In simple terms, whenever one object exerts a force on another, the second object exerts a force of equal strength or magnitude, but in the opposite direction back on the first object. This means that forces always come in pairs. One force is the action, and the other is the reaction, and they act on different objects. These action-reaction force pairs happen simultaneously and are responsible for many everyday experiences such as walking, swimming, jumping, and a lot more. Understanding Newton's third law helps us explain how motion is influenced not just by a single force, but by the interaction between two objects, pushing or pulling against each other. These ideas might sound a bit abstract, but don't worry. Let's walk through a few quick examples to see how action and reaction forces show up in real life. Let's take something we all do every single day: walking. It might not seem obvious, but every step you take is actually a demonstration of Newton's third law in action. When your foot pushes backward against the ground, it might feel like you're simply propelling yourself forward. But what's really happening is an exchange of forces. This backward push is the action force. You're exerting a force on the ground. Now, according to Newton's third law, the ground doesn't just sit there. It immediately pushes back with a force that's equal in strength but opposite in direction. This is the reaction force, the ground pushing you forward. It's that forward reaction from the ground that actually causes your body to accelerate and move forward. If the ground did not push back, like when you are on a slippery surface, like a wet floor, you wouldn't be able to walk properly. You'd push backward, but there would be no reaction force to push you forward. Picture yourself doing some home repairs. You grab a hammer, position the nail on the wood, and take a good swing. As the hammer strikes the nail with force, something interesting happens. The nail doesn't just stay in place, it reacts. According to Newton's third law, for every action, there's an equal and opposite reaction. So, while the hammer pushes the nail into the wood, the nail also pushes back with an equal but opposite force. You have probably felt that sting in your hand after a solid strike. That sensation is a reaction force. The nails push back on the hammer. Even though you can't see it, it's there in the form of vibration. Think back to the opening scene. You're standing on a small boat floating gently near the shore. As you push off the boat to leap forward into the water, you suddenly feel the boat slide backward beneath your feet. You make the jump, but the boat drifts in the opposite direction. Why does it happen? According to Newton's third law, whenever you apply a force on something, it applies an equal and opposite force back on you. So, when you push against the boat to dive forward, that was the action force. At the exact same time, the boat pushed back against you with an equal force in the opposite direction. That's the reaction force. Because the boat has less mass and is freely floating, that reaction force makes it move noticeably backward. So, what have we learned today? Remember that Newton's third law of motion tells us that for every action, there is an equal and opposite reaction. This means that forces always come in pairs. When one object pushes or pulls, the other object pushes or pulls back with equal strength or magnitude in the opposite direction. These forces act on different objects, happen at the same time, and help us understand interactions like walking, swimming, hammering, or even jumping off a boat. In everyday life, motion is never just about one object moving. It's about how two objects interact through the forces they apply to each other. Understanding this law helps us recognize that every movement involves a partner, whether it's the ground beneath your feet or the air beneath a bird's wings. Thanks for watching. Like and subscribe for more videos coming soon. And that's it for today. See you next time and stay curious.